Alright, so our next question for the video is from 1.35 from NCRT. The question says calculate calcium carbonate reacts with aqueous HCl to give calcium chloride and carbon dioxide. There's a balanced chemical equation given to us. What mass of calcium carbonate is required to completely react with 25 ml of 0.75 molar HCl? So here we need to find out the mass of calcium carbonate when the molarity is given to us. So first let's write down the parameters given to us. So here we are given with molarity, which is equal to 0.75 molar. Then we are given with volume, and for molarity volume has to be in liters. So the volume given to us is 25 ml. When we convert it to liters, it's going to be 0.025 liters. Now we'll write down what is the formula of molarity. Molarity is equal to number of moles of solute divided by volume of solution in liters. So here if you see, we know what is the volume of solution, we know what is the molarity, but we don't know what is the moles of solute. So first thing is we need to find out the number of moles of solute. So here we will write down number of moles of solute is equal to given mass by molecular mass. So out of this, molecular mass is easy for us to calculate. So let's calculate that. So here molecular mass of HCl. We need to find out the value for HCl. That is equal to 1 plus 35.5. 1 is for the atomic mass of hydrogen and Cl is 35.5. When we calculate, you will get 36.5 grams. So we know what is the molecular mass. We don't know the given mass. So now whatever values we have, let's just expand the number of moles here and put all the values. So therefore, molarity formula, I'm just rewriting. Molarity can be under expanding number of moles, that is given mass by molecular mass into the remaining part of the denominator, which is volume of solution in liters. So now we know the molarity, we know the molecular mass, we know what is the volume. We have to find the given mass which is asked in the question. So let's write down the values. Molarity as per the question is 0.75, which is equal to given mass is taken as X. We don't know that. Molecular mass we just calculated 36.5 into volume. We know what it is. It's given in the question 0.025. Now when we find out the X value, it is going to be 0.6843 grams. So this is going to be our value for the given mass from the formula. Now our question isn't complete yet because this is the X value for HCl. But as per the question given to us, it says what is the mass of calcium carbonate. We need to calculate that. So here we need to know what is the molecular mass of calcium carbonate first. So for calcium carbonate, our molecular mass is going to be 100 grams when we calculate it. So we are going to use that one. So therefore, from the balanced equation that is there in the question, right, we have 1 mole of calcium carbonate reacting with 2 moles of HCl. So here we will write 2 into 36.5 grams of HCl. The reason why I am writing like this is because 36.5 is the molecular mass of HCl which we just calculated. But 2 because if you check the question, the equation has 2 moles of HCl there. That's why it's 2 into 36.5. This will react with 1 mole of calcium carbonate. That 1 mole of calcium carbonate, what is the molecular mass? 100 grams of calcium carbonate. Therefore, this much of HCl will react with how much of calcium carbonate? That's what we're going to write. So here, this much 0.6843 grams of HCl reacts with X grams of calcium carbonate. We need to find out what that X grams is. So we just cross multiply. So X is equal to 0.6843 into 100 divided by 2 into 36.5. Now when we simplify this entire thing, our answer is going to be 0.937 grams of calcium carbonate. So this is going to be the answer for the question asked. So first you find out what is the given mass of HCl. From that it's easy for us to calculate the mass of calcium carbonate required for this much of HCl.